triangles where you don't have the side across from the given angle, and we have to still be able to see if we can solve those triangles as well. So we're going to look at the other set of formulas, and that's for the law of cosines. And this is in your packet on page 13. So the law of cosines works when you have three sides. So if I have side, 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 no way we can use the law of sines, because you have to have the angle across from one of those sides and you use the law of sines. And it also works for side, angle, side. So it says for a triangle with sides A, B, and C and opposite angles, we can still keep these as A, B, and C. There are two forms for this. And the reason there's two forms is because are you solving for an angle or are you solving for the missing side? So depending on what form we're looking at or what information you're given, you'd use one form versus the other. So the standard form is when you're given side, angle, side. So this would be the initial form that was kind of created for the law of cosines. So that means when you have side, angle, side, you have a side, an angle, and then another side. So side, angle, side. You've got the side, the angle in between, the other side. So law of sines cannot work, because for law of sines to work, I would have to have the angle across from one of the two sides or the side across from the given angle. So not an option for us to use. But instead, we can use this law of cosines. And the law of cosines says the side you're finding, that's what A is going to represent. So the side we want to find, pretty much the side we don't know, is equal to the other two sides that you're given. B squared plus C squared. I need to let Pythagorean do. So I'm going to solve for my third side using the other two sides and squaring them, adding them together. But then we're going to subtract 2 times both of those sides along with the cosine of the side across from the angle, or I'm sorry, the angle across from the side. And again, like you're going to be given those pieces of information because the other two sides are my B and C, and the angle would have to be A, because it's not across from the side that we're looking for. Okay.
In that first part with the squared equals B squared plus C squared, is that solved? Would that be solving for the third side?
It would be solving for the third side, yes.
So you wouldn't do Pythagorean theorem then replug everything in?
We can't use the Pythagorean theorem because it's not a right triangle. So that's why there's extra stuff behind it. So because it's not a right triangle, we can't just say B squared plus C squared would have to equal my other side. Other questions? So the other form, which is called the alternate form, would be for side, side, side. Which if it's side, 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 you have all three sides. But remember, the smallest two sides have to be greater than the third side for that triangle to exist. So take a peek at the three sides that you're given. Make sure the two sides that are smallest are bigger than the third side. So this form is just taking standard form and isolating the cosine of the angle. Because if I have three sides, the only option is to solve for an angle. So if I want to get the cosine of an angle by itself, I would have to take the cosine to the other side, take it to the left, and take the a squared to the right. So it still is saying b squared plus c squared, but if I'm moving a squared to the right, we have to subtract it to the right. So that's why it's now being subtracted. So it's just rearranging that form to get cosine by itself. And then cosine is being currently multiplied by 2bc. So again, to get it by itself, we would have to divide it by 2bc. They are the same form. It's just rearranging the standard form to get it into this alternative form, or I call it angle form, so you can find the angle. So if I'm solving for the angle, I can isolate the cosine and get it by itself. If we're finding a side, we have that side we want to find by itself. In the end, anytime you're finding the angle, we'd have to use the inverse for the alternate form. For the standard form, you're going to take the square root to get the a by itself. We're not going to do the proof to this. It is in your book. It involves finding the sine of angle A and the cosine of angle A. It involves also the distance formula and then two of the identities, the double angle identity and the Pythagorean identity. It's a little more involved. Jared's shaking his head. Say, thank goodness we're not doing that. So it's a little more involved than the law of sines proof. But it is in the book if you want to do it. I kind of gave you a little bit of information about it. It's not like a 3-step proof. It's got like a couple of 5, 6 steps, a little bit of substitution, and then using two of those identities. Yeah, I mean, according to Mr. Warnock, that's a short proof still.
It's like half page.
Yeah, he's like a 30-step proof kind of guy. He loves doing proofs.
That's like a medium proof for him.
Yeah, did you have Mr. Warnock?
Yeah.
Yes, he loves
And I
doing
mean, I have him for study hall next
Oh yeah, you guys have heated conversations in there, I hear.
Yep.
I got to skip.
All right, so if you look at the first example at the bottom of the page, this is, I really think it's pretty straightforward as long as you can plug stuff into your calculator correctly. So pitcher's mound on a softball field is 46 feet from home plate. It's different for baseball than it is for softball. The distance between the bases is 60 feet. How far is the pitcher's mound from first base? So if I'm the pitcher, which probably wouldn't be good, but maybe I'm the pitcher, and ball was hit directly to me, I'm throwing it to first base. What's the distance that I would be throwing it to get the runner out? What do you think you do to try and start solving the problem?
Well, I drew
You drew?
triangle
A-
first.
You drew a triangle first?
Yes. Whoa, we're getting high tech. here.
I know, right?
Oh.
I'm gonna draw a diamond. What? How's that
Okay,
look?
Not what I was doing.
Could have done it bigger.
Does that look pretty much like a diamond?
It's
It's
a
like a
square.
Square?
That's
It's like a
square.
rectangle square.
Well, it's supposed to be a square.
That's very
Congruent diamond.
I mean, but it's equal.
It's
between the
close.
bases.
Yeah,
You're
it's
fine.
pretty good. I think that's pretty good.
I can draw a better square.
See.
Prove it. Prove it.
Prove it. Do it.
All right. So David said he drew a triangle, which no problem, draw a triangle. But I figured I'd draw a
Really
softball diamond or a baseball diamond. We know that the distance between all the bases is 60. You don't have to label all of them, but if this is my softball diamond, anybody play softball, baseball? You play baseball, that's right. Do you know what the distance between the bases for baseball?
90. Oh,
It says
sorry.
90. I don't know what, I know it's shorter for
The
some.
mound is 60 and bases are
60.
90.
And I think right now Addie plays 12U softball, and I'm going to say like hers is not at 46 yet. It's a little under. Not quite at 40. She also doesn't pitch. All right, so we have our pitcher's mound, and it says the pitcher's mound is not halfway between home plate and second base. So I'm making sure I'm not putting it halfway. I just put it somewhere a little closer. And I'm drawing a vertical line down to home base, home plate, and that is 46. So if I'm standing on the pitcher's mound and I throw to first base, we want to know that distance. So if you drew just a triangle, that's fine as well. Just kind of gets you to think what's going on here. So what's the problem with my diagram?
You don't have enough information.
Wait, what information do you need yet?
But you need a third something.
You need a third something, because right now we have two sides and a missing side. We can't use Pythagorean theorem, because it's not a right triangle. But there is still something that's there that's implied that really isn't there. Aaron?
It's an angle between, well, it's a square, right?
Yeah, it is a square, because it's a baseball diamond, and if it's a true baseball diamond on a professional field, these are all right angles. So Aaron, that would make this angle down here
45
45 degrees,
degrees.
because the baseball mound is supposed to be directly in line with home plate. And even, I think in high school baseball, they still try and get that all lined up, just like a football field, try and get it all lined up nicely. So how would you set up then the formula for the law of sines? Or I'm sorry, law of cosines. So we have side, angle, side. So how could we set this up? How would it look like? David?
Is a squared gonna be?
Yeah, and I'm just going to call it x squared. So whatever piece you're solving, x, a, b, c, like that's the part you're solving. I have it as an x if you'd like it as an a, you can have it as an a.
So the 46 squared plus 60 squared minus 2 times 46 times 60.
And then finally the cosine of
45.
45.
It's a lot of numbers.
It is a lot of numbers. So that's why the law of sines is easier because you don't have as many numbers to plug in and make a mistake with your calculator. You can plug this in all at once into the calculator. You don't have to plug it in separate pieces.
Really?
Yeah. Just make sure that you're multiplying that second part together. So I put parentheses around the 46, the 60, and then the cosine of 45. You can put it all in one step.
I'm having a hard time reading this number here.
So it should be a large number,
Yeah.
and then you're going to do what with that large number?
Square root it.
Make sure you use the whole answer. Use the second answer function. Don't round it.
Wait, what should we have gotten
You know what, I
Before you
didn't have
square
it.
rooted, it's 1,812
there?
Point something.
Yeah.
Point
Yeah, I got the two.
Yeah, so when you square it,
Oh,
it's
I didn't.
42.58.
Yeah. Put it all in. Okay, so because this stuff here has to be multiplied by the cosine. That's
That would be the error.
There you go. And then second part. Square root it, second answer. So you should have gotten 42 point, and that is 8. Anybody not get it?
So in every circumstance, you put the unknown side as a.
Yes, exactly. So the unknown side is your A. That's going to be on the other side. The other side you don't know. Oh, look. There you go, that's it. And then skip the whole thing. Alright, so we're going to do one other problem. Short day, 2 examples. So if you flip and look at the top of the next page, so that you can see how it works when you're trying to find the angle. The other example that I have up here, you are asked to find 3 angles. So I don't know any of the angles, but it says the sides have lengths of 8, 19, and 14 feet. And then with the little stars there, it's a good idea to find the angle opposite the longest side first. And then you go down on your page a little bit and it asks you to think about why. Why do you think it'd be a good idea to find the angle opposite the longest side first?
Oh. Well, would that be able to tell you if it's an obtuse triangle or not?
Yeah, I'd be able to tell you if you start working with an obtuse triangle or an acute triangle based off of getting that biggest angle. And it actually does make a difference, not on all of the problems, but some of them, if you don't find the biggest angle first, then the other angles aren't going to kind of match correctly. So find the biggest angle, you get that biggest angle out of the way. So if you don't want to draw the diagram, you don't really have to for this, but sometimes a visual. We don't know if it's acute or obtuse right now, so you just have to draw yourself a regular triangle. A is 8, B 19, C 14. So we're going to find angle B first because 19 is the largest side, which is side B. So when you're setting this up,
That's really wrong.
it's make sure you use the other 2 sides. So you're not using 19 for the minute. We're taking the other 2 sides those get added together. You subtract the side that is across from the angle. So the side that's across from the angle, that would be my B. So that's the part that you're subtracting. And then you're dividing that by 2 times those other 2 sides. So if you're solving for angle B, you're subtracting B. If you're solving for angle A, you're subtracting A. So whatever side you're solving for, whatever angle you're solving for is the side that gets subtracted. So again, just be careful when you're putting this in your calculator. I think you might need to put an extra set of parentheses around the bottom part, depending on how your calculator is set up. If you have a calculator that already puts it in fraction form, awesome. But this morning it was seeming like the extra set of parentheses around the bottom was kind of necessary so that the fraction knew that everything on the bottom was grouped together.
Oh, that is not.
And then you're using the inverse cosine of whatever number you get there, and make sure you're using the whole
I
number.
got -0.45.
Got negative 19,956.
How did you get that?
Do second cosine.
Oh.
Even I didn't get that.
Yeah, that's okay.
I'm the one that normally
Wait, is
gets
it
it wrong.
negative 4.5?
And then do second cosine, inverse cosine. Yep, that's it.
Well, they tricked us.
Oh.
It's up
It is an obtuse, so you don't really know it's obtuse until you calculate the angle.
It's ironic because a triangle like here, that's the smallest angle I drew.
I don't
That's
think
why.
Are we supposed to round all these ones or do we? Wait, what did I?
Are you supposed to?
Round whenever it's
Good,
cosine?
Lucy, is this?
Because I got like -0.45.
So use the whole thing.
First you got negative 19.
And then
Because you
round
said
back
second-
to the
second
whole.
negative.
I just
That's not
said
the
this
answer.
parentheses.
So, yeah, you need a parenthesis right in front of the two. So try
Okay,
again, put
thanks
it
for
in
reading.
parentheses. So
Oh, yeah, you
make sure you're using the whole answer, don't round. Use the second answer function, and after you take the inverse cosine, you should get 116.8. And that is angle B. Now, how could you solve for one of the other angles? Yeah. So you don't have to use the crazy cosine formula again with all the extra numbers added to it. So Emily said use the proportions. Go back to sine. Now that I have an angle that's across from a side, to me it's way easier to plug in numbers for the law of sines. You're going to get the same exact answer. Because you could use the other one. You're still finding angle whatever you're solving for. But I think it's easier to use law of sines than cosines. That's just me. If you prefer to go back to the cosine and plug it in a second time, you can do that as well. So you could use the alternate formula, you could use the standard formula. Emily, which one did you find, A or C?
I found A.
You found A? So A, sine A, and Emily, what'd you get for the A?
22. Oh,
Did you find C?
yes. And then I got 41.
Okay, so you found C.
Yes.
All right, and C you said was 41.12.
Yes.
Yes, okay. Again, you could use the law of cosines, this same formula, the angle formula. You could go back to using the standard formula because now you have side angle side set up, or you could use the law of sines. And then Emily, you were giving me angle A as well, which was
22.08.
22.08. Pretty straightforward.
Yeah.
Questions? We're not going to do the third one. I was going to give you your test back, but I'm going to have to kick Curtis out. Sorry.
Great.
Questions?
Yeah.
Alright, so your homework is the homework for Monday. So on the assignment